Hello, everybody, and welcome back to another installment from our series Straight from the Horse's Mouth. How can we safely operate within the environmental limits without causing permanent harm to Earth? Here is where planetary accounting comes into play, which quantifies what can we do without pushing the Earth beyond certain limits. Here's a sneak preview.
There are 9 planetary boundaries that we need to respect if we want to have an Earth system that stays in that Holocene-like state. We need to respect all of these limits if we're going to have an Earth system that is conducive to ongoing human activity. We need to understand what each of us need to do to restore the planet to those planetary boundaries and to be able to retain a healthy planet. Not only would this give you the context of what good luck looks like for the t-shirt, but it would also start to let you to compare products across dissimilar categories. We can set corporate planetary science-based targets. So a lot of companies these days are setting science-based targets for carbon. This would allow us to set science-based targets across all of these indicators.
But the problem that you've got is that planetary boundaries doesn't define flows. It doesn't define pressures on the environment. Instead, what it defines is limits. The challenge you've got is it's very hard to take information that's related to a product, which defines an amount of emissions, an amount of carbon dioxide or methane, or a certain amount of resource that you're extracting from the Earth's crust. It's very hard to then use those numbers and translate them to a state of being, what the state of the atmosphere is.
Life cycle assessment and planetary accounting work together to minimize long-lasting or irreversible damage from our activities. LCA calculates how much water is consumed, carbon is emitted, and land is used to create a product and sustain it over its lifetime. With that, let's get started.
So hello everyone and welcome to our webinar. Today's topic is planetary accounting, going beyond carbon. This webinar forms part of our series Straight from the Horse's Mouth, Insights from Experts in 30 Minutes. My name is Jeff Vickers. I'm Technical Director at thinkstep-anz, and it's my pleasure to host you for the next 30 minutes. So I'd like to introduce our topic today, which is how we can integrate and use planetary boundaries through the concept and through the lens of planetary accounting. And I'm delighted to welcome today Kate Meyer, Founding Director of Planetary Accounting Network. Kate is a passionate person about helping society live within limits. As part of her role, she wears many different hats, both as the founding director of PAN, but also in her role as Becca and her role as a mother. And maybe in personal life, this wasn't part of her bio, but Kate has recently moved to Wanaka, and that's something I'm a little bit jealous of. So Kate's going to be introducing the planetary accounting concept to us today, and then I'm going to be adding a little bit more color about how we link it together with life cycle assessment. So with that, I'd ask Kate to take us away.
Today, I just want to do a bit of an intro to planetary accounting, just sort of stepping back for a moment, though. We talk a lot about this whole decade as the decade of doing, or the decade of decarbonisation, and a lot of news and media talk about this as the most important decade in human history, and that by 2030 it could really be too late to save the planet. And I think it's important to just reflect on that concept for a moment, because actually this graph here shows temperatures on Earth over the last 500 million years. And if you look to the sort of left side of the graph, you can see that actually 500 million years ago it was about 14 degrees hotter than it is today. And at many moments over the Earth's history, it's been, 4 to 6 degrees cooler than today. And so when we're talking about 1.5 degrees of warming or more than that as being really catastrophic, it's actually important to reflect on what's at stake, because it isn't the planet. I'm pretty willing to bet that even if we get 10 degrees of warming, the Earth will continue to rotate on its axis and orbit around the sun. So if we zoom in a little bit onto this graph to the last 400,000 years, it looks a bit like this, a bit like a heart-shaped, a heartbeat pattern of temperatures going up and down. Humans turned up about 300,000 years ago. And so for much of our history, actually, the temperatures were much less stable than they have been lately. And it has been quite a lot warmer and quite a lot cooler than today. But what's important to note is that during that time, for 290,000 of the last 300,000 years of our whole history, so almost our entire history, we lived as hunter-gatherers. And what's really interesting is what played out over the last sort of 150,000 years or so, because it was the first time we ever left Africa. So right up until about 80,000 years ago, all humans lived in Africa. And what happened is as the temperatures dropped, we went into an ice age, and the land masses become a lot closer together because the sea levels drop. As the sea levels drop and the land masses came closer together, about 100,000 years ago, people started to try and migrate out of Africa, and 80,000 years ago were successful. The first modern humans left Africa and started to migrate through the Southern Arabian Peninsula, and by about 60,000 years ago, made it all the way through to Australia. Then about 12,000 years ago, temperatures warmed up. And what's interesting is all of a sudden, after 290,000 years of being hunters and gatherers, agriculture suddenly appeared in 4 different locations around the Earth. Now, the reason that that's really crazy is that it happened in this tiny blip of time, about 1,000 years. So that sounds quite a long time on our human life scales. But if you look at it on the graph, it's just this minute blip in human history. And this was in 4 pretty distinct locations around the world. There wasn't any way to give your mates a call across the world, or zoom in to say, hey, I've figured out how to grow some carrots, here's the news. And so what it suggests is that we had that knowledge and that expertise for a really long time, way back to when we were all in Africa, and that it was actually the change in the temperatures on Earth that enabled that agricultural revolution. And then all of a sudden, in only 10,000 years, we've gone from hunter-gatherers into this modern society that we all live in today. And so when we talk about what's at stake in the next 10,000 years, it's really that. It's the ability to have agriculture, to have regular seasons, to have this modern advanced society that we have today. It isn't about saving the planet, it's about saving people. I think until about a decade or 15 years ago, people spent a lot of time trying to work out, what were the Earth's limits for humans, the carrying capacity of the planet. And the problem with that is it's so heavily reliant on a lot of assumptions about the lifestyles that we might have, or activities that we might do. What constitutes a reasonable lifestyle from one study to another study varies so much that the greatest assumption is that we could have 23 to the trillion humans on Earth, but that relies on cannibalism as a source of food. And so you can see how much the assumptions vary. And so in 2009, there was quite a big breakthrough when a bunch of scientists got together and they said, actually, what we need to say, what do we need to do to make the planet look like the last 10,000 years that has been so conducive to human history? It's called the Holocene period, the last 10,000 years. So what are the parameters that would help us to stay within the Holocene? We talk a lot about climate change and about carbon, and how emissions could, if we emit too much carbon, that we could push ourselves beyond sort of safe limits and get irreversible runaway change. But actually, it's not just about carbon and climate change. There are 9 planetary boundaries that we need to respect if we want to have an Earth system that stays in that Holocene-like state. Climate change is one. Some of the others include biosphere integrity. So how many species there are, or global extinctions, land system change, and really specifically looking at how much deforestation there is, freshwater use, ocean acidification, air pollution. We need to respect all of these limits if we're going to have an Earth system that is conducive to ongoing human activity. After the planetary boundaries were published, a lady called Kate Rayworth came along and she said, it's all very well to have these environmental ceilings, but we do need to respect these. But if they are really about human well-being, what about social foundations as well? And so she came in and added this lens. And I think this is quite a popular framework these days, if you've heard of donut economics, and basically the goal for us all these days should be to operate within the green space in this donut. So that respects those planetary boundaries on the outside and social foundations on the inside. But, you know, we have this this urgent challenge ahead of us. You know, how can we respect the planetary boundaries and meet these social foundations in time that we have a chance to stabilize our Earth and avoid a hothouse Earth scenario. But the challenge is actually, what do we need? What can we do about it? So we can look to life cycle assessment and environmental accounting tools, and there are a lot of tools that we can use to work out the environmental footprints of various products. So I could ask Jeff to quantify how much impact these t-shirts have on the planet, and, you know, Jeff might say, you know, it's got 1 ton of carbon, it's got 20,000 litres of water. I could actually put some of those numbers into context. 20,000 litres of water would fill up 3 sparkles. The problem with that is, so what? What do these numbers mean? Is that a lot of water? Is it not very much water? How does that much water affect these planetary boundaries? And the problem with the planetary boundaries is, while they tell us that there's this really big urgent problem, they don't actually help us to answer what to do about it, or help us to provide that context of what good looks like. The reason for that is actually just all about metrics and the types of metrics that are used. And so, as an example, the planetary boundary for biodiversity loss is a maximum global extinction rate. We can have up to 10 extinctions per million species in the world each year. What does that actually mean to any of us? You know, we've just had these global negotiations in Glasgow. If they were trying to talk about biodiversity, what would we have said in New Zealand? Well, I think we'll have the tui, thanks. We'd like to make the tui and the kiwi extinct. You know, it's not a metric that makes sense to scale and to look at different options. We can't look at, you know, what is ThinkStep's impact on global extinction rates. They don't connect up. And so I guess to sort of explain that in a way that is maybe easier for some of us to relate to, I think that the helpful thing is to imagine that you go to a doctor, and the doctor measures your heart rate and your weight and takes your blood pressure, and then she shakes her head and she says, "Oh, it's very bad news. You've got tachycardia, your blood pressure's through the roof, you're obese. If you don't do something urgently, it's all over." And then that's it. She sees you out the door and on your way for the rest of your day. Of course, that's not what she would do. She would give you a prescription. She would say, all right, to resolve these urgent challenges, you need to, I don't know, walk for 20 minutes a day. She would say you need to have a diet of only this many calories, or she might say you need to take this much medication. Whatever she told you, it would be measurable, quantifiable, and it would have been calculated based on what you need to do to return to good health, to restore your weight or your blood pressure or your heart rate to what it needs to be. So they would return you to good health. And so that's exactly what we need for the planetary boundaries. We need to understand what each of us need to do to restore the planet to those planetary boundaries and to be able to retain a healthy planet. And so that's what planetary accounting is really all about. It translates those global outcomes, the planetary boundaries, into global budgets, prescriptions that we all need to adhere to. It sets out 10 different environmental currencies that we need to manage. And then from those global figures, we can start to break those down to say, well, what does good look like at my level of influence? So, you know, if we return to the story of the t-shirt, you know, we can say, well, there's 20,000 litres of water in this t-shirt. That's 3 sparkles worth of water. But we can actually say, hey, if we divide up the global budget for water, that's about 1 day's worth of water for my budget. And so you suddenly can get this context that you didn't otherwise have. So one of the neat initiatives that we're working on that that Jeff's been involved in with us as well is developing these planetary facts labels that would allow you to actually see this data in the context of these limits. So just like we go and scan into every sort of shop and cafe these days, you could scan a barcode or a QR code on your products and services, and it would say, there's 8 grams of carbon in this and this many litres of water, and this is this percentage of a recommended average daily budget. Not only would this give you the context of what good luck looks like for the t-shirt, but it would also start to let you to compare products across dissimilar categories. So you could start to look at, well, what's the difference? How does my milk compare to my t-shirt compared to a flight to Fiji that I want to take next year? And to start to balance that whole environmental impact of your lifestyle, like we'd manage budgets from our bank accounts. I think the neat thing about planetary accounting is that it really helps you to set out a vision for the future. So it's not a, incremental change, where do we need to go, but where do we need to be in future, so that we can start to work backwards and see what is the roadmap to help us get there. Our kaumatua at PAN gave us this proverb to describe what planetary accounting is about sort of fundamentally, and it goes, kia tō te rangi Māori o te rangi tu ito nei, o papatua nuku e takato nei, o te taiao e awhi nei, ki ranga I a tātou tihe wā Moriora. And basically what it means is that it's only when the heavens and the physical world are driven or controlled by the active participation of kaitiaki that we can have true sort of well-being. And it's really about enabling that kaitiaki role for all of us, so that whatever our scale of influence, we can see how much we need to be doing to play our role. So as an example, we could use it as regional planners. We could start to set out, what does this city or this region look like within the planet's limits, and start to develop roadmaps to enable us to get there. We can set corporate planetary science-based targets. So a lot of companies these days are setting science-based targets for carbon. This would allow us to set This allows us to set science-based targets across all of these indicators. Planetary boundaries has already been used at a national scale in New Zealand, and to develop methods for other countries. Planetary accounting would give a connectivity between those different frameworks across different countries. But I think what's really valuable about it is it's not just that you can use it in all these different ways, but it actually helps you to connect up the dots from all these other aspects. And I think what's important to note is that it's not actually about reinventing the wheel or developing new frameworks, but just taking all that context and providing a new lens to make it consistent across different things, and to give that context with science, to help us all sort of work together and figure out how we can operate within the planet's limits. Just a final couple of minutes just about planetary accounting and who the network and who we are. So we're a charitable trust that is now based in Wanaka, as Jeff said, but with a global outlook. We're a relatively small core team, but we expand and shrink to demand based by working with delivery partners. And so it's really exciting to have ThinkStep as one of our key delivery partners. We've got a really incredible advisory group that is comprised of a number of different international scientists from around the world, and also some amazing experts in sort of law and governance and international negotiations. And so they help us to make sure that our framework stays up to date with all the latest science, and that what we're doing is really robust. And then we've got a fantastic and quite quickly growing network of members. So if any of you think that your organisation would be interested in joining the network, we'd love to have you. So on that note, I'll pass back to you, Jeff.
Thank you so much, Kate. What an interesting presentation. What I'm hoping to do today is build a little bit on what Kate was presenting. And what I wanted to do is connect planetary accounting to life cycle assessment, and to talk about how we link product level footprints up to global limits. And so I wanted to really touch on the so what question that Kate raised before. When you do a life cycle assessment or product carbon footprint, you end up with numbers. My carbon footprint is 7, be that 7 kilograms of CO2 equivalent or 7 tons of CO2 equivalent or whatever it is, it doesn't really matter, but you get numbers that are quite hard to interpret. And what people actually want to know is my product sustainable or not? I don't really know what the carbon footprint is. It means nothing to me, but is it sustainable? And there's kind of an old joke in the life cycle assessment community that the answer to any question is it depends. It depends on a whole range of factors. It depends on the resource use and emissions from making your product. It depends on the number of products that you manufacture each year. It depends on the resource use and total emissions of all products, both in your region and globally. So we're not just interested in what you're making, but we're interested in the sum total of what society is making and the effect that that has on the environment around you. And you're interested in the current state of the environment and the distance from key limits, which is where planetary boundaries can help. And just kind of picking up on Kate's point before, the current state of the environment is incredibly important. If we were heading towards another global ice age, we'd be going, hey, carbon dioxide, let's emit more of that because we want to warm the planet up so it doesn't get too cold. As it stands, as we move towards the hothouse Earth type scenario, we're trying to take carbon dioxide out. And I think, we do need to be conscious of the fact that things aren't inherently good or bad. They're just things. Emissions are what they are. Some of them are positive, some of them are negative, and your perception of positive and negative depends on the current sort of state and what you want to be there. The other challenge with life cycle assessment kind of comes back to planetary boundaries as well, is that we're dealing with lots of different environmental indicators. So we're dealing with climate change through the indicator of global warming potential, for example. We're dealing with indicators like acidification potential, which contribute to acid rain or ocean acidification. We're dealing with things like eutrophication potential, which contributes to algal blooms, for example. We're dealing with photochemical ozone formation, which contributes to summer smog in big cities, for example. And we're dealing with things like water scarcity, among many others. And there's lots and lots of different environmental impacts that we can consider. And so when you sort of do that work, you do a life cycle assessment, you do an EPD, you get a series of numbers. And what I'm presenting on the screen today is an EPD from our client Asaleo Care, which is now Essity Australasia. I decided to pick toilet paper because it kind of seems to be the product of the pandemic. Everyone's been rushing out to get toilet paper in case we never had enough of it. And so what you can see here is you can see a whole range of numbers. The numbers are quite different in scale. Some of them are negative, some of them are positive, some of them are in the thousands, some are less than 1. And the challenge with these is that not only are they very different numbers, but they're very different units and they're measuring very different things. And so the challenge is that we can't easily compare across these rows because they're not all the same unit of measure. They're not all doing the same thing, they're all telling us the same thing. And so the way we tend to handle that in life cycle assessment is using something called normalization. And rather than trying to define it myself, I rather thought I'd just present the ISO definition, which is that it's the calculation of an indicator result relative to some kind of reference state. And the aim of normalization is to understand the relative significance of different impact categories. So for my product, should I maybe be interested in carbon footprint, or should it rather be acidification or depletion of resources or whatever it happens to be? And importantly, what normalization is doing is dividing by a reference set of information to give you just a set of indicators with no units so that you can make comparisons across them. And the most common way of normalizing your results is to divide by current emissions, so the current emissions of a person in a year. And the problem with doing that is that current doesn't necessarily equal sustainable. And so just because we're doing something in one way doesn't mean that that's the way that we can continue to do it in the future if we want to remain in the sort of stability domain that we're currently in, where we're currently living in Earth, the Holocene style climate that Kate was referring to, moving into the Anthropocene. And so it's, if we had this idea of we want it to normalize to sustainable levels, how would we do that? And so I became interested in this question of normalizing to sustainable levels in about 2006, 2007. And then along came planetary boundaries in 2009. And I thought, happy days, I've got my solution. I can just use planetary boundaries and apply that to life cycle assessment as like a normalization technique to give us a relative significance of different environmental impacts and help to make sense of the information. But the problem that you've got is that planetary boundaries doesn't define flows. It doesn't define pressures on the environment. Instead, what it defines is limits. The limit of atmospheric carbon dioxide is 350 parts per million, in the atmosphere. And that's interesting, but it doesn't relate to what we're getting out of a life cycle assessment or carbon footprint, which is our emissions of carbon dioxide are. We can't relate that easily to a state. And so the problem is that, and by the way, the red ones are the ones we're exceeding, not to highlight them in any other way, but the challenge you've got is it's very hard to take information that's related to a product, which defines an amount of emissions, an amount of carbon dioxide or methane, or a certain amount of resource that you're extracting from the Earth's crust. it's very hard to then use those numbers and translate them to a state of being, what the state of the atmosphere is. We need to make it more in terms of flows, how much is going out in a year, for example, so that we can then try and understand what that means. And so that's where planetary accounting comes through. And I've just borrowed Kate's graphic here just to kind of try and explain it. I don't want to go into the detail because it's a bit too much to cover. But the point is that the planetary boundaries are the blue things, and the pressures or flows are the things here. And that's what's been added by planetary accounting. And the importance of adding that is that you can define what planetary accounting calls quotas. And then we can use those quotas to help define what we need for doing normalization. And so when you look at this from a quota perspective, you get things that are much more useful from a life cycle assessment and carbon footprint perspective. There are things that are gigatons of CO2 per year, or megahectares per year, or whatever it happens to be. They're flows of stuff in a size that relates to a time period that we can start to relate to and we can do something with, rather than being a state. And so, what planetary quotas, planetary boundaries, planetary accounting, the combination of those things together gives us is it starts to help us get closer towards the so what question for life cycle assessment. My carbon footprint is 7. Well, so what? What does that mean? And it helps us to understand what those numbers mean and their relative significance. But there is still a bit more work to do. So one of the things you may have noticed if you are watching closely is that some of the numbers are negative. So we need to put things back in some cases. So if I flick back here, you can see some negative numbers here. So just as Justin Timberlake brought sexy back historically, we need to bring forests back, and we need to take carbon dioxide out of the atmosphere. So we've got things here that we have to do to restore as well as to conserve. So there's a challenge here where we're talking about restoration to put things back, as well as conservation to preserve what we have left. And we need to try and deal with those two things together. And so we have to do that, but we also have to look at how we can assess and consider local and regional impacts as well as global ones. Because while global limits are incredibly important, we also have local issues and regional issues which we need to deal with together. And that's not necessarily the challenge of something like planetary accounting, but it's something we need to be conscious of as well. And I see that we've got one coming through already, which is a question for Kate, which is that you mentioned that the social foundation aspects has been added to the planetary boundaries model. Does the planetary facts label incorporate the social foundations in any way?
That's a really good question, and the short answer is no. The longer answer is when Kate Rayworth came over to New Zealand last year, Kate and I sat down and had quite a long discussion on how could you apply that same thinking of the translation of planetary boundaries at outer circle to that in a circle. And it's actually a lot more challenging because there's not a clear scientific link between sort of actions and outcomes, and it's still quite complex on the environmental side. It's even more complex on the social side. So while we're not doing that specifically on planetary facts, we are looking at whether at what we can add to that in terms of addressing some of those social elements, talking about some of the existing metrics that are out there that address some of those social indicators. We are trying to incorporate more directly those social elements in terms of when we're setting the city and regional planetary accounting applications, because it's a lot easier in those applications because you can sort of talk to whether it's having positive change or negative change as opposed to specific quantification. So definitely something that we're aware of and would like to incorporate, but it's not as systematic.
Great, thank you very much. There's another question here regarding how you see New Zealand's current global contribution to life cycle assessment. Are we a leader in certain areas of life cycle assessment? And is New Zealand a leader in planetary accounting from your perspective?
It'd be interesting to get you to answer the where you see our life cycle assessment skills from New Zealand on a global platform, actually, Jeff. On planetary accounting, it's Planetary Accounting Network and all planetary accounting work is now coming out of New Zealand. So yes, I'd say from a planetary accounting perspective, we're globally leading. There's a lot of application of planetary boundaries in Europe, and so Stockholm and Germany, the Potsdam Institute in Germany and Stockholm University are the two places that most of the planetary boundaries applications are coming out of outside of New Zealand. Yeah, Jeff, you'd be more qualified than me to speak about LCA.
From a life cycle assessment point of view, I'd say we're certainly not leaders, unfortunately. Most of the life cycle assessment work has been developed out of Europe and North America over the last sort of 30, 40 years. But I would say we punch above our weight. So I'd say we operate on par with anything that's done internationally. But certainly, we're not a big producer of life cycle assessment, on the international stage. What I think we do well in Australasia is I think we communicate better. So I think our communication of life cycle assessment and environmental product declarations and that kind of thing, I think that's done better in Australasia than it's done in, say, Europe, where it can become very technical. And you get just these sort of data sheets of stuff which no one can interpret, and they're just pumped out in the hope that someone gets what's meant. And I think that's a dangerous place to be, and we try to avoid it. So there's a couple of other questions here. Are you working with Kogo? That's a very direct one. Kate?
No, we're not at the moment. Kogo is pretty awesome platform. It takes quite a different approach in terms of the way that it aggregates, and we're taking more of an LCA bottom-up approach. So they are quite similar focuses with different approaches. I see that there's quite a lot of alignment as well, and certainly am keen to talk to the Kogo team more about potential in future, but not at this stage.
Cool. And from a thinkstep-anz side, we do a little bit of work with them. When are the planetary facts labels that you're designing ready?
Yeah, that's a great question. Look, it really that depends quite a lot on how much funding and support we manage to generate for the next stage. We're sort of closing in on the first stage of the methodology refinement. It's a very complex challenge that we've taken on, and it's pretty exciting working through it. I think we've come a long way this year. I'd like to see some pilot labels on the shelves in the next 12 months, but I'm not sure. I'm not sure is the answer. We are looking for more partners and funders, so if you'd like to get in touch, please feel free to.
Exactly, good plug, to contact. How does the accounting system include irreversibilities and tipping points?
So the planetary boundaries includes that. So we're in the danger zone for climate and carbon emissions. We're not at the end of what they consider the red zone. They were in orange zone. We're actually beyond the orange zone for biogeochemical flows and for biodiversity loss. So we're beyond theoretical limits for some areas. There's a high level of interconnectivity between them all that is quite hard to take into account in an accounting framework, but we are working with some people over in Portugal who are quite interested in how you'd add dynamics to the model. So it'd be interesting to see if we can do that in a future iteration. There is some level of consideration of the interconnectivity in terms of that really complicated diagram that Jeff threw up on his slides, which just sort of shows that each of the quotas is related to very many of the boundaries to kind of capture some of that. Yeah, exactly. So the arrows going everywhere to say, this land use change one over here is connected to climate change and atmospheric aerosol loading and all these other things. So it's still an accounting framework. So it says here's the limits that return to. So for the ones who are over the safe limits, as Jeff said, they're negative budget. So we've got to have a negative, like a withdrawal of carbon dioxide out of the atmosphere, a reforestation, and then some of the limits are sort of a net zero to allow for the fact that there may still be some positive impact, and we can potentially counteract that. So for example, imperishable waste allows for future technologies like landfill mining, which it's an existing technology, but it allows for growth and that sort of give and take.
Would the data gathered from an EPD be useful for planetary and carbon accounting for a company?
Yes, absolutely. I mean, I guess the planetary facts labels are in essence just a window to an EPD. if you like. It's a nice way of communicating that data and context. It's as far as possible aligning the methodologies so that it would just connect in together.
And then maybe as a final one, is there a way to find out more about the methodology? So where can people find additional information?
There's some additional information and links to the publications. There's actually a whole textbook on planetary accounting. So there's links through to that and through to the sort of papers on our website, planetaryaccounting.org. But the website's actually under upgrade at the moment, so things like the projects we're working on are just they'll be back online soon. We've just had so much growth in the last few months that we've had to do a big refresh. So if there are specific pieces of information that you're keen to delve into, do feel free to give me an email at kate@planetaryaccounting.org. I'm happy to point you in the right direction.
Thank you very much, Kate. And with that, I think we better wrap up. I see there's quite a few more questions. We'll have to come back to them by email after this. So thanks everyone for your interest. And I'd really like to take the time to thank Kate for joining us. Really appreciate your insights today. Thank you also to the audience for joining us and for all the questions. Really appreciate your engagement. So thanks all for your time. Have a fantastic day. Bye all.